Now we will discuss regarding insulator, how the insulator can be charged. One thing I have written in the blue color, please read it very carefully, that if any charge is given to the insulator, it will remain at the location where you are charging, because insulator charges are not free to move. Now, there are you can say two methods for charging, that is a conduction, induction. Of course, one method is there also friction. What is the basic meaning of these terms, conduction, polarization, induction, that I am going to explain here. Conduction, as I told you earlier, it shows the physical contact. Here there are two bodies. I hope it is visible to you. In the diagram number B, that initially body A is neutral, and when you bring some positive charge body near to it, the body will get same type of the charge due to the physical contact or conduction. Now, what is polarization? Polarization simply polarization, again I am telling you, simply to explain the shifting of the charges. Initially we say this body is neutral body, having some positive charge, negative charge, like this. This is neutral body. When you bring a nearby positive charge rod, what will happen? This positive will repel the positive, so positive will move far away, and positive attract the negative, negative will move closer to this body. This shifting of the positive charge and negative charge, or you can say shifting of the center of the positive charge and center of the negative charge, is known as the polarization. This phenomenon in physics is termed as polarization, and this charge is known as a bound charge, and this charge is known as a free charge, that you should know very well, because you can remove this charge, but this is the bounded charge due to this nearby positive charge, so this is known as a bounded charge. And then induction. Firstly, you will polarize the body, then you will ground the body, and with the help of the grounding you can charge it, that is known as the induction method. Of course, we will discuss these things in detail, just I am giving you a brief idea what you understand by the conduction, polarization and induction. You just read it for your knowledge. Okay. Again, whatever I have shown in the blue color, please read it. All the individual strands of the hair become charged, and same charge body always repel, so they begin to repel each other. You should understand it. Okay. One very simple question is here. Just pause the video and try to solve it. जैसा कि अभी आप लोग जानते नहीं है, पोटेंशियल के बारे में हमने डिस्कस नहीं किया है. अभी आप लोग इस तरह की जब क्वेश्चन आए तो आप चार्ज टू साइज रेशियो आप निकाल लीजिए. सबसे पहले काम तो आप ये कीजिएगा. जैसे आप यहाँ चार्ज टू साइज रेशियो निकालेंगे, चार्ज टोटल हो गया देखो 6Q प्लस 13Q माइनस 4Q. If I am not wrong, I think we get 13, 6, 19 minus 4, we are getting the 15Q. And what is the size? That is 3R plus 2R plus R, I will say 6R. Now you can build the logic. If size is 6R, charge is 15Q. Now different sphere having different size, 3R, 2R and R respectively, you can calculate like shown the slides. One thing I want to tell you very clearly here. If bodies are perfectly identical, suppose I say these are the identical bodies, body A, body B and body C. Identical means they are of same material and same size or design. Of course here size is different, it is visible in the numerical. So if bodies are identical, then charge will be equally distributed when you bring them in contact. Suppose I say this body A is having 0 coulomb charge, this body B is having 12 coulomb charge, C is also having, suppose I say this body is having 3 coulomb charge. So when you bring them in contact, total charge is 15 will be equally distributed, and body A will be having the charge of 5 coulomb, this is also having charge of 5 coulomb, this is also having the charge of 5 coulomb. But this equal distribution is valid when bodies are identical. Identical means same shape or same design, otherwise it is not possible. Okay. Somebody can ask you why insulator cannot be charged by conduction. I think it is very simple thing for all of you. Conduction means movement. In insulator, all of you know very well, charges cannot move easily. So how the conduction is possible? Pause the video and read it carefully. Now, for the charging of the insulating body, the very important principle is there the friction. If you want the insulating bodies, if suppose I say body A and body B both are insulating, either these two bodies are insulating, either at least one of these two bodies should be insulating, otherwise the friction method is not applicable. So, and I say there are two body A and B, you rub with each other. In the second diagram it is shown to all of you. You are rubbing to both the bodies. What is shown to you? Body A is having more electronegative. So what will happen? Body A will attain the negative charge by rubbing. I am showing the next slide also. Like here the glass rod in silk. No. If I rub it, what will happen? Glass rod is losing the charge and same amount of the charge is gaining by the silk. So silk is getting the negative charge. Again I rubbing it, glass rod is getting the +2 charge, silk is -2. Again you can think the conservation of charge. Isolated system glass rod and silk net charge is 0. You can show this activity at home also to your brother or sister. You can take the balloon, you can rub with the hair, you can rub with your woolen cloth and bring it close to your hair. What you will say, hair will be attracted toward this side, so you will explain the polarization. With the polarization the body is attracting. Okay, just think the answer of this question, because I will show only in the slide. Touching, conducting and non-conducting balloon, very good concept. If I say there are two balloon A and balloon B, and I am telling you that the balloon A and B both are giving some charge. I don't know what of the charge, it may be positive, it may be negative, it doesn't matter. No, if I say this is the metallic balloon or conducting balloon and this is the non-conducting or non-metallic balloon, like this. No, as I told you, if it is a metallic balloon, you will touch, what can be happen? Through your body the charge can leak to the ground and this body can be neutralized. But same phenomena will not happen in the non-conducting balloon. Here if you are touching the balloon, you will see in the coming slides that you are making it reverse. You are giving it more charge, because insulator cannot be discharged when you touch it, because their charges are not able freely to move. So you can make it more chargeable body if you are touching it, because friction is there and friction always creates the charge. Now I am discussing the charge induction concept in metal bodies. Just think it. As I have shown here, if a positive charge body is brought close to neutral body, what will happen? This body is neutral body. Of course there are plenty of free electrons in this body and they can move freely. Now what you will say, if positive charge body is brought close to it, then what will happen? This positive charge body will attract the negative charge, like this. Negative charge will move toward this side, because there is a positive charge zone is there. So when the negative is moving toward this side, deficiency is known as the positive charge will be created on the surface. Here also positive charge will be created, like this. I have to show it here only because charge already sent on the matter in the outer side. Now this phenomena I told you, this is known as the polarization. When you बाई चांस आप लोग क्या करते हैं, इस बॉडी को अगर आप दूर ले जाते हैं तो वापस क्या होगा, ये बॉडी न्यूट्रल हो जाएगी. पॉजिटिव नेगेटिव डिफ्यूज हो जाएंगे, बॉडी न्यूट्रल हो जाएगी. तो तब तक ही पोलराइजेशन रह पाएगा जब तक पास में एक चार्जेबल बॉडी है. Okay, so as I told you, near to the positive side minus Q charge will be developed and away plus Q charge will be developed. And what is the relation of charge on this charge and induced charge? This is known as induced charge, that I will discuss in the coming slides. Here how much charge can be produced here. Okay, a positive charge body is brought near a uniformly, this is a uniformly charged metallic sphere. Now suppose I bring a positive charge here. Now here it is uniformly charged sphere, it is visible to you. It means charge density is uniform everywhere. As I bring positive charge body near to it, what will happen? All of you intelligent. Again electron will be coming from this side to this side, like this. Now, as the electron is coming from this side to this side, here the diffusion will be there, and here the electron is moving from this point, the more positive charge will accumulate here. It means at this surface positive charge density is decreasing, and here the positive charge density is increasing. Like you can read the slide. No, if a negative charge body is close to the uniformly positive charge body, then what will happen? Again, you will say this is negative charge body, it will repel the negative from this side to this side, because electron can freely move. So when the electron is moving from this side to this side, here the deficiency zone will come, it is a positive charge, here also positive charge, and when the electron will come here, it will diffuse here. So again what you will say, here the charge density will increase and here the charge density will decrease. One very important thing is written here, induction takes place only in bodies, not in particles. So please mind it very carefully. Okay, now I am explaining you charging by induction concept. So just listen it. Suppose I say in the very first diagram, this is neutral body. I said this is diagram number 1. This is neutral body. Close to neutral body I bring a positive charge body. Now what will happen? All of you intelligent, polarization will be there. Negative charge will come here, positive charge will come here. Now again if you take this rod away, then again this body will be neutral. Of course neutral, but shifting of the charge will not be there. Now what will happen? In the presence of this rod, you are grounding this body. In the second diagram, I hope it is visible to all of you. When you ground it, what you will say? Electron will come from the ground. They will diffuse the positive charge. This positive charge disappear here. I think it is visible to all of you. Now suppose at this moment you take away this rod far away, then what will happen? Again the electron which come from the ground, they will go to the ground. Again positive charge will be created here. Same neutral body is there. But in the presence of this rod, as I told you earlier also, I think, this charge is known as the bound charge, this charge is known as a free charge. This is free charge. So they can move it. Now when I disconnect it, in the second, third diagram, you are disconnecting it. Now what will happen? The bounded charge will remain here. And now you take away this body far away, this charge will be uniformly distributed. So what is important here? You are charged the body with the help of the induction. Induction means without physical contact. Without physical contact. Now one thing is very very important here. अगर आपने यहाँ पे मिस्टेक कर दिया सोचने में, तो यू आर कंसेप्चुअली इट विल बी वेरी बिग मिस्टेक बाय ऑल ऑफ यू. सबसे पहले आपको इसको डिस्कनेक्ट करना है, उसके बाद इसको दूर लेके जाना है. कहीं ऐसा नहीं हो कि आप पहले इसको दूर लेके चले जाओगे तो क्या होगा, जो भी अर्थ से चार्ज का ट्रांसफर होता है वापस पोटेंशियल सेट करने के लिए चार्ज का वापस ट्रांसफर हो जाएगा और वापस बॉडी क्या बन जाएगी आपकी न्यूट्रल. सो ऐसी मिस्टेक नहीं करें. सिमिलरली अगर यहाँ पे आप इस बॉडी को मैं पॉजिटिव चार्ज लाया था, हो सकता है इस न्यूट्रल बॉडी के पास में आप लोग नेगेटिव चार्ज रोड लेके आ जाओ, तो क्या होगा, इंडक्शन मेथड होगा, यहाँ पे पॉजिटिव चार्ज आएगा, इंडक्शन कितना होगा हम डिस्कस करेंगे अभी. यहाँ पे नेगेटिव चार्ज हो जाएगा. Again you people will speak, this is the bound charge, this is the free charge and this is the bound charge. No, what you will say, in the presence of this rod, this is negative charge rod, you ground it. Suppose you are grounding it like this. Now what will happen? Electron will move to the ground. As I told you, any amount of the electron can be given to the ground, any amount of the charge can be taken from the ground. So again you will see here a positive charge will remain. Now you disconnect first, then take it away. Now what will happen? This body will get the positive charge uniformly distributed. So I think I have made it very much clear to all of you, charging by induction or without physical contact. You just go through the slide which I have shown here, you will get the better idea. Pause the video, read the slide. There are 3 activities are shown here. You can read it because we have discussed all the concept. Working of photostat machine. Let me show you slide very carefully. How the photostat machine work, how you get the print on the white paper which you should put in the photostat machine. Just read all the steps 1, 2, 3. I have shown up to steps 8 and you will get the idea. Okay, now I am showing the animation for this charge induction concept. Whatever I told you, just see the animation very carefully. All of you just look, as I bring the positive charge, what will happen? Polarization will be there, yes. I hope the video is moving very slowly. You just have the patience, please. These electrons are coming from far side, and as the electrons are coming, they are creating the positive charge on that side. कभी कभी आप ऐसा भी सोच सकते हो पॉजिटिव विल रिपेल द पॉजिटिव, बट ऐसा नहीं सोचे. यू जस्ट सीइंग द मूवमेंट ऑफ द इलेक्ट्रॉन्स ओनली. लाइक दिस इज द पोलराइजेशन. अगर आप अब इस चार्ज को दूर लेके चले जाओगे यहाँ से, तो आप देखोगे वापस बॉडी क्या हो जाएगी आपकी, न्यूट्रल बॉडी. जैसे आप इसको लेके जा रहे हैं, आप देखिए आपकी बॉडी वापस न्यूट्रल बॉडी हो गई. अब आपने क्या किया, वापस पॉजिटिव चार्ज पास में जाएगा. अगेन यू विल से पोलराइजेशन विल देयर, शिफ्टिंग ऑफ चार्जेस. पॉजिटिव एक तरफ चले जाएंगे, नेगेटिव एक तरफ चले जाएंगे. मोमेंट ऑफ नेगेटिव यू विल थिंक, एंड एफिशिएंसी विल क्रिएट द पॉजिटिव चार्ज. One side is minus q charge, of course. For that side, I think it is not visible on the screen. It should be plus q charge, because this body should be ultimately neutral. Now, as I told you, uniformly charged body, uniform positive charge is there. Now you bring some charge body near to it. Suppose this is a positive charge body. Again, you will say positive charge body will attract the electron. और जैसे वहाँ से इलेक्ट्रॉन आ रहा है, देखो पीछे आप देख रहे होंगे, वहाँ पे ऑन दिस साइड यू आर ऑब्जर्विंग द पॉजिटिव चार्ज, एंड हियर द डिफ्यूजन इज देयर. सो चार्ज डेंसिटी इज मोर हियर, हियर चार्ज डेंसिटी इज डिक्रीजिंग. आगे जाके आप इसको सेंटर ऑफ पॉजिटिव चार्ज सेंटर से भी समझ सकते हैं कि पहले सेंटर ऑफ पॉजिटिव चार्ज सेंटर पे था, अब पीछे चला गया था. अगर आप नेगेटिव चार्ज बॉडी लाए तो क्या कहेंगे, देखो पहले तो आप बोलेंगे सेंटर एग्जैक्टली यहीं पे है. अब देखो नेगेटिव नेगेटिव को रिपेल कर दिया, तो यहाँ मोर पॉजिटिव चार्ज हो गया. पीछे के पॉजिटिव चार्ज देखो आप देख रहे होंगे स्क्रीन पे डिफ्यूज हो रहे हैं. अब सेंटर ऑफ पॉजिटिव चार्ज थोड़ा इधर शिफ्ट हो जाएगा. तो आगे आप कूलम्स तो लगाओगे, थोड़ा आप लॉजिकली आप सोच सकते हैं इंडक्शन का इफेक्ट. अब हम डिस्कस करेंगे इंडक्शन इन एटम एंड नॉन मेटल. हियर यू विल से दिस इज एनी एटम and nucleus, all of you know, and this is the electron cloud. Of course, center of the positive and center of negative are one side. Now, if I bring any charge body near to it, suppose I bring the positive charge body, then what you will say? You will say electron will be attracted toward this side. So this electron cloud model will be distorted. It will disturb like this, and this positive will be repelled by this nearby positive charge. Now you will see initially center of the positive charge and center of the negative charge are coinciding, but when you bring a nearby charge body, center of the negative charge will come toward this side, center of positive charge will shifting this side. This phenomena is also known as the polarization. We have discussed it. This is the polarization in atoms. Just read all the slides carefully. I will show this activity in the animation also. Okay, if there is a how you can practically show the process of the polarization in the laboratory. Just see the animation here.
Anna.
And I'm Steve.
And this is a piece of PVC pipe.
And this is a plastic cup that has a hole drilled into the bottom of it. So when I fill it with water, it leaks out of the bottom.
If I charge the pipe and then bring it close to the stream of water, the water is attracted to it. That's because water molecules are polar molecules.
Water molecules look a little bit like Mickey Mouse. The two hydrogen atoms are bunched up on one side of the oxygen atom, and while the molecule itself is neutral overall, it has a positive end and a negative end because of the way it's shaped. Molecules, like water, that have an asymmetrical distribution of charge are called polar molecules.
Let's say the pipe has a negative electrical charge. If I bring it close to the stream of water, the water molecule flips so that the positive end is pointed towards the negatively charged pipe. Opposite charges attract, so the water is drawn towards the pipe.
This is an experiment you can do for yourself at home fairly easily. All you need to do is turn on the faucet so a little bit of water comes out, and then you place a charged object near the water. Any object that'll hold a charge will do, like a comb.
Or a balloon that you've rubbed on your head.
Or a plastic pen.
Thanks for watching. I hope you'll join us again soon for another experiment.
Okay, in this slide what I want to explain you, polarization is not charging. कभी कभी बच्चे सोच लेते हैं कि पोलराइजेशन का मतलब होता है चार्जिंग. पोलराइजेशन जैसे मैंने ब्लू कलर में लिखा हुआ है, when an object become polarized there is simply a redistribution of the center of the positive and negative charge within the object. That is the polarization. Of course, if you grounding it, then there may be possibility you are getting the charge. Now, if it is a non-metal, number of atoms are there, you bring the positive charge body near to it, again you will say the distortion of these all atoms will take place and orientation will be toward this side. That is very very important. I think we have shown in the diagram. Yeah, this all of you will say, firstly we will say all the atoms will be polarized. This polarized center of the positive and center of the negative charge shifting, positive will repel the positive, but here the all of you are checking it, this orientation is towards the positive charge, so that is very very important. Then in junior classes I think आप लोगों ने सबने किया होगा, you take paper pieces, take the scale, rub to your dry hair, scale is getting charged, you bring nearby to the papers and papers are clinging to the scale. आज आपको क्लियर हो गया होगा कि पेपर क्यों स्केल पे चिपक रहे थे उस टाइम में. रीज़न इज दैट द पेपर में पहले पोलराइजेशन हो रहा था, तो अब आप देख रहे होंगे नेगेटिव एंड पॉजिटिव चार्ज में डिस्टेंस कम है, नेगेटिव नेगेटिव में डिस्टेंस ज़्यादा है. इसका मतलब फोर्स ऑफ अट्रैक्शन विल बी मोर कंपेयर टू फोर्स ऑफ रिपल्शन. सो अल्टीमेटली दिस पेपर इज द टेंडेंसी टू अट्रैक्टिंग टुवर्ड्स द this I have shown the comb. You can think with the glass scale also. Bound charge, free charge, I think I told you very much, you can understand it. Okay, is it possible to create a net charge on a conductor via induction without grounding it? अभी तक जो भी मैंने डिस्कस कर रहा था इंडक्शन का प्रोसेस में चार्ज, वो सब मैं ग्राउंडिंग करके बता रहा था. क्या बिना ग्राउंडिंग के भी पॉसिबिलिटीज है? देखो मैं स्लाइड से दिखा देता हूँ. आप दो कंडक्टिंग स्फेयर ले लीजिएगा जो दोनों टच कर रहे हैं, बट दे शुड बी ऑन द इंसुलेटिंग स्टैंड. यू ब्रिंग द पॉजिटिव चार्ज बैलून नियर बाई इट, व्हाट विल हैपन? ऑल ऑफ यू नो, इलेक्ट्रॉन विल बी कमिंग टुवर्ड द राइट साइड, एंड जब इलेक्ट्रॉन उधर से इधर आ रहे हैं तो वह डेफिशिएंसी हो जाएगी, वजह से पॉजिटिव चार्ज लाइक दिस. अब इस चार्ज की नियर बाई चार्ज बॉडी, जो नियर बाई चार्ज बॉडी में दिखा रहा हूँ, इसी की प्रेजेंस में इन दोनों स्फेयर को आप दूर दूर कर लीजिए, क्योंकि अगर आप पहले इसको दूर लेके चले गए तो वापस स्फेयर न्यूट्रल हो जाएंगे. तो इसी के प्रेजेंस में आप दोनों को दूर कर लीजिए. इंसुलेटिंग स्टैंड है तो आप यहाँ से पकड़ेंगे तो कंडक्शन नहीं होगा, दूर कर लिया, और फिर उस बॉडी को आप दूर ले जाओगे तो चार्ज विल बी यूनिफॉर्मली डिस्ट्रीब्यूटेड. मैक्सिमम वैल्यू ऑफ द इंड्यूस चार्ज, ऑफ कोर्स दिस कंसेप्ट विल कम इन द कैपेसिटर, बट यहाँ पे मैं आपको एक फॉर्मूला याद कराना चाह रहा हूँ बच्चों, कि आप ये फॉर्मूला अच्छी तरह याद कर लें. दिस फॉर्मूला कि maximum value of the induced charge will be given by q dash minus q 1 minus 1 by k. k is the dielectric constant, जो हमें कैपेसिटर में समझ में आएगा ज़्यादा, लेकिन बेसिक कंसेप्ट है, आपको फॉर्मूला जरूर आना चाहिए. एंड वैल्यू ऑफ द k इज डिफरेंट फॉर डिफरेंट मटेरियल. k फॉर द मेटल इज नोन एज द इनफाइनाइट. अगर मैं मेटल की बात करूं, k फॉर मेटल बॉडी इज टेकन एट इनफाइनाइट, दिस इज k. अब आप यहाँ पे के की वैल्यू इन्फाइनाइट करोगे तो क्यू डैश की वैल्यू कितनी आ जाएगी, माइनस क्यू। यानी मैक्सिमम अगर कोई मेटेलिक बॉडी है, सपोज आई ब्रिंग ए 12 कूलम चार्ज एंड दिस इज मेटेलिक बॉडी, the maximum charge which can be induced here, that will be minus 12 coulomb maximum charge. Negative sign, why it is coming? Because you are bringing positive charge body near to it. All of you know, that's why I have shown the negative sign here also. That is also visible to this negative charge like this. तो आप अभी केवल फॉर्मूला याद कर लीजिए, q dash equal to minus q 1 minus 1 by k, and value of the k is different for different material. I will discuss later. Okay, can you tell me, can two similarly charged body ever attract each other? Like one is a positive charge body, another is also positive charge body. Yes, there is a possibility. When it is not point charge, it is big size body, induction will be there. और इंडक्शन में क्या होगा, एक तरफ पॉजिटिव चार्ज इकट्ठे हो जाएंगे, एक तरफ नेगेटिव चार्ज इकट्ठे हो जाएंगे, और अट्रैक्शन की पॉसिबिलिटी हो सकती है कि फोर्स अपोजिट चार्ज के बीच में ज़्यादा हो जाएगा, वो पास पास में है तो। रीड द स्लाइड। कैन टू सिमिलरली पॉइंट चार्ज, देखो मैंने यहाँ पे पॉइंट चार्ज लिखा है, आप ध्यान से पढ़िएगा इस क्वेश्चन को। दिस इज द पॉइंट चार्ज बॉडीज, पॉइंट में तो इंडक्शन होगा ही नहीं, तो वहां पे आप नहीं कहेंगे कि अट्रैक्शन इज पॉसिबल इन द सिमिलरली पॉइंट चार्ज बॉडी। ओके, इन द नेक्स्ट वीडियो लेक्चर आई विल डिस्कस द गॉडलीफ इलेक्ट्रोस्कोप।